All right. So today's lesson is on polygons. Polygons. It's a fancy word for shapes. Okay. All right. Now, before we get to our polygons, we're going to do some conversions. Tuesday, we started taking the little practice assessment, the yearly practice assessment, and they had some conversion stuff on there. It's been a while since we've done it, so we're going to have to discuss it. All right. So we have a few different prefixes that we need to talk about. So kilo. A kilo equals what? 1,000. This is volume 2. It's chapter 12, lesson 1. Okay. The next one we want to talk about is milli. What is milli?
Million.
No, it is not a million. Centi is 100. But it's not 100, it's 100. So it's 0.00, not 0.00, 0.01. So milli, is that bigger or smaller than centi? Smaller. And it's 10 smaller, so it's 0.001. So that's thousands. Okay? And then you have your grams and your meters, which are your standard unit. Okay? So 3,000 milligrams equals how many grams? Well, how many grams? Milligrams. So milli.
Oh.
How many of those would it take to make a gram?
100.
If we did 100, then we would have, check it out. We would move this twice, right, for the 2 zeros in 100. So we would have 0.1. So how many would, yes?
3.
It's 3 grams, yes. Now we have 0.05 or 5/100ths of a kilogram. And how many milligrams is that going to be?
1,000.
So let's see. Let me erase our little thing here. There's my decimal. So we start off with how many zeros here? How many zeros?
3.
3. And then how many more?
4.
4, 5. So what we need to do is move this 5 times. 1, 2, 3, 4, 5. So how many zeros do I need to add?
5.
No.
6. 3.
I need to add these 3. Okay, so I messed up because we talked 1, 2, 3, and then we only counted the zeros here, but because this is after the decimal, we need to count that as a 0 too. So there should have been 6 zeros, which means we go 1, 2, 3, 4, 5, and one more. So that's going to give us at 50,000 milligrams. Sorry. So now we have 4,500 grams, and we're converting that to kilograms. 4.5, very good. And our last one is 8 kilograms to grams. Yes, 8,000. Okay, very good. Now we're going to start talking about shapes. It says, how do you determine whether a two-dimensional figure is a polygon? There are 3 criteria. 3 criteria that you should remember. 1, are all the sides line segments? Okay, what does that mean? That means that the sides are straight and they have a beginning and an end. Okay? 2, is it closed? Huh? Said 3, right? Our third criteria. Do the sides intersect? Or cross each other? So these are the 3 questions that you ask yourself. Okay? So let's look at our square right here. Are all the sides line segments? Yes, they're straight and they start and they stop. Right? Is it closed? Yes, there are no openings in the shape. Do the sides cross each other? No. They meet, but they do not cross. So this is a polygon. Okay? So this would be an example of a shape that is not a polygon. Why is that not a polygon?
Because they cross each other.
Yes, right. Okay. How about this?
Yeah.
Yes.
Because it has a...
All right. So all we would do is count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 sides. They're all line segments, right? And it's closed, so that is a polygon. All of our shapes over here, let's see, our parallelogram. Is that a polygon?
Yes.
Yes. Another parallelogram, is it a polygon?
Yes.
Triangle, is it a polygon?
Yes.
Our square, we already talked about the square, it is.
Yes.
What is this?
Trapezoid.
All right, I'm going to show you something that this is how I always remember trapezoid. Okay? We'll insert a page right here because I think that this is important. Page, let's go before. Boom. Okay, so trapezoid. Oh, I don't have a trapezoid to pick, so I have to draw one. Okay, so this is a trapezoid. I have always thought that the trapezoid looks like a circus tent. Right? What do they do in the circus?
There's elephants in there. They do tricks. That's all I know. Tigers. They cross each other.
No, what's that thing called? They do it over a net, and they have another little thing.
They shoot you out of a cannon.
And they have another one. Another person usually is over here. It's the trapeze, right? And they usually swing back and forth and do tricks and stuff. So see, the trapeze is in the circus, which belongs in the trapezoid. Okay? So that's my easy way to remember that shape is called a trapezoid. I don't know if it's easy, but I bet you can't forget it now. Okay? All right, so we talked about all these shapes. This last shape has 1, 2, 3, 4, 5, 6 sides. What's it called?
Octagon.
Oh, hexagon. Octagon has 8 sides. Okay, is it a polygon? Yes, it is. All right. Now we're going to determine whether each figure is a polygon, and we're going to explain why or why not. Let's start with our first one. It's our triangle, but there's something up with our triangle. It looks a little different than most. Is it a polygon?
No.
No. Why is it not a polygon?
Because it's not an angle triangle.
No, it has right here. It is not a closed figure. Number 2.
No.
Why not?
Because they cross. They intersect.
Because our sides intersect, huh? The sides cross each other. We'll just say intersect. Intersect means cross. Our next one.
Yes.
Yes. Why?
Because it's closed.
Sides are line segments.
Those 3 reasons. And then it's closed. They do not cross each other.
It's closed. And sides don't cross. Do not intersect. Next one.
No.
Is it? No, why not?
It doesn't have side. The sides aren't line segments.
The sides are not line segments. It's not made of line segments. And our last one. Yes. It's a weird looking shape, but it is a shape. Okay. And just because I don't feel like rewriting all this, we're going to go like this. No, not like that. Not like that. Come on. Come on. I just want this part. Oh, it's not going to let me do it. Shoot. Yeah, probably, huh? All
Why
right.
don't you just do it like that and then erase the not made of line segments?
That's all right. I'll just type it. Make it small. Boom, 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 boom. Boom. All right. So, sides. Are line segments. It is a closed shape. and the sides do not intersect. There it is. Okay. There you go. I typed it all for you. Now you guys can read it easier. Okay. Yes. How can I help you? Stretching? All right. Sorry. Don't mean to bore you so much that you're going to fall asleep. All right. Our example in your book.
What page? Whoa. 903. You got that.
Okay. So the building shown is the Pentagon in Washington, D.C. We're going to describe the sides of the figures formed by the red outline. So look in your book. There's a red outline. All right. Does the red outline form a polygon? Well, let's talk about that first. Is it a polygon?
Yes.
Yes. So yes, it is a polygon. Now, the figure has blank sides. How many sides does the figure have? 5. Do the sides ever cross each other?
No.
So that is why the figure is a polygon, just like we were talking about with our last page. Okay. Now, a regular polygon is a polygon with congruent sides and congruent angles. Congruent sides are equal in length. Congruent angles have the same degree of measurement. So, here it is. Congruent side, all the angles and sides are congruent. Now, what I can tell you about most of your polygons. In fact, all of your polygons. If the sides are the same length, the angles are automatically the same. Just something about the way that in order to get the sides to meet at a single point, it makes all the angles the same because the sides are the same length. Okay? So whether you're talking a triangle, a square, a pentagon, an octagon, a hexagon, if the sides are the same exact length, they all have the same exact angles where they meet. Okay? So I know some of you are going to be like, well, the sides are the same, but I can't tell if the angles are. They are. If one's the same, the other's the same. Okay? It's impossible to make a shape with all the same angles and not have all the sides the same length. Just like it's impossible to make a shape with all the same length sides, but yet have different angles. Okay? Well, mostly. You can take an octagon and flip 2 of the sides to the inside, and then you wouldn't have a regular octagon. But if you go in the same direction all the way around the outside, the angles will be the same. Okay? No. So our second example. We're not taking a test today because we're doing the interim test for the SBAC. So all day Tuesday we tested, so therefore we have to squeeze in our math lessons on Thursday. All right? Good news is that besides your homework that you was due this week, your tests are done. So if you don't like your test grades, you should have fixed the problems that you got wrong. Because tomorrow, the last assignments will go out. There won't be any new assignments for math before report cards come home. So for the third quarter, the fourth quarter grades will start next week. Okay, so example 2. If we're going to determine if the polygon appears to be regular or not regular. So let's look at it. The top and bottom sides appear to be what than the other sides? So they want us to look at the top and bottom. So they want us to look here and here. Now how would you describe those sides compared to the other sides? They're longer. Now, are all 6 sides of the polygon congruent? No. Because congruent means equal, right?
Yeah.
So no, they are not congruent because they are not equal. We just said that two of them are longer. So, is it a regular polygon or a not regular polygon?
No.
Not regular. All right. Now just above that, in your book, you have a chart. We're going to fill this chart out together.
Oh my God.
Okay.
That's a. Yeah.
It's just above that on the next page.
Look at the trash.
All right. So we're going to complete the table below. We're going to ask for the number of sides, and then we're going to draw another polygon that is not regular. You can see as we go through here. We have a triangle, a quadrilateral, a pentagon, a hexagon, and an octagon. Now, the triangle and the quadrilateral, as long as all the sides are the same, the angles will all be the same. The hexagon could actually be inverted to where it's coming this way, so where the sides could be the same, but yet the angles wouldn't be the same. Okay? So as soon as you go past 4 sides, there is a chance, but it's very obvious when they do it. So, like for example, the pentagon right here. The pentagon, it's still a pentagon if the sides are coming in this way. All the sides can still be of equal length, but the angles aren't. Okay, so it's not regular. Does that make sense? You guys understand what I'm saying? Okay. So that's what I'm saying. It will be very obvious to you if the sides are the same length, if the angles aren't. Because like down here with the octagon, right? Same thing. It could come in this way. It's still an octagon. These two lengths could still be the same length, but it's going to be very obvious that it looks like Pac-Man and not a regular octagon, right? All right, you guys understand what I'm saying? All right, cool. So let's start with the triangle. So the number of sides for the triangle? 3. So the prefix tri means what? 3. Now it wants us to draw another triangle that is not regular. So anything where the sides are not equal is a not regular triangle. Okay? I know it looks like I just kind of drew one that's flipped over, but that's all right. Quadrilateral. How many sides are in a quadrilateral? 4. So quad means what? 4. So it wants a regular quadrilateral. So almost, as long as it's not a square. A rectangle is not a regular quadrilateral. A trapezoid is a not regular quadrilateral. All right. The pentagon. How many sides does a pentagon have? 5. So penta means 5. So I just told you in a regular pentagon you can draw like, as long as it has 5 sides. Okay. I know it doesn't really meet too well right there, huh? Sorry. There. Is that better?
Yeah.
All right.
Looks like a bed.
Yeah, it does kind of, huh? All right, my next one. How many sides is in the hexagon? 6. So hexa
Means 6.
means 6. And I have to draw an irregular hexagon. 1, 2, 3, 4, 5, 6. There. And the last one that we're talking about on our chart is an octagon. An octagon has how many sides? 8. So octa means, and there's my octagon. All that matters is it has 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay? If I rotate this a little bit, it'll look like a duck. Duck. Oh, that's what it is. It's a sock. It's an elf shoe. Right there. Alright, moving on.
But elf shoes are like this.
Elf shoe. Alright, guided practice. We're going to name the polygon. We're going to determine if it appears to be regular or not regular. So, most of your homework today is going to be determining whether polygons are regular or not regular. You will have other homework where you need to draw not regular or regular polygons. Oh, tricky, tricky, tricky. You need a ruler. Well, think about it. If you're going to draw a regular polygon, all of these sides need to be the same length. Now, if you do not have a ruler, you can use something that is straight. For example, I will just, let's say I have a piece of paper. Here's my piece of paper. You guys like my piece of paper?
Yeah.
It's pretty awesome, huh? On my piece of paper, all I have to do is make one mark. Well, why isn't it making marks? Oh, because I'm on yellow, huh? Alright, so I can just make one mark and 2 marks. And so now, when I draw my stuff, I can just say, okay, and draw it from mark to mark, and then rotate it, and draw it from mark to mark here, and mark to mark there. And now I just made myself a homemade ruler. Does it matter what the length of the side is? No. It just matters that they're all the same. Right? Okay. So now, back to our problem. Our guided name the polygon. How many sides does our polygon have? 8. So the polygon has 8 sides. Now, your homework does not have a wonderful sentence. The polygon has 8 sides. The sides appear to be blank. It is a blank. So what I want you to do is write inside the shape the number of sides it has. Okay? And then next to it, I want you to write either congruent or not congruent. Are the sides congruent? They are. So we're going to write congruent on our sentence in our example because that's what it's asking us to do. But for your homework, I want you to write congruent next to the shape. If it's not congruent, you're going to write not congruent. Not just not. You're going to write not congruent. Shh. By telling you the number of sides and whether or not the sides are congruent, you can then determine whether it is regular or not regular, and you can determine the name of the shape. The number of sides tell us the name of the shape. So, the number of sides on this is 8. So what kind of shape is it? Octagon. So it is a octagon. Now, whether or not it is congruent will tell us if it's regular or not regular. In this case, it is congruent, so it is a what kind of octagon? Now, if you want to write regular octagon instead of octagon regular, that's fine with me. Okay? I just want to know that you know the difference. All right? Now, so when you're doing your homework, the number of sides inside the shape, whether or not it's congruent, written next to it. Then the name of the shape and whether or not it is regular on the bottom. So you have three things. The number of sides. In this case, the number of sides is 4. Is it congruent or not congruent?
Yes.
It is congruent. So you're going to write congruent next to it. And then you're going to write what the name is. And and whether or not it is regular or not regular. Okay? Do you guys understand that? So you're going to do that through number 5. Now number 6. The ones that say not regular. I would appreciate if you use a straight edge, but obviously you don't need a ruler. But let's make the line straight so we can tell that they're line segments. You can see that I'm freehanding my shapes while we're doing our video. And some of my shapes, the line segments don't look like line segments, huh?
Yeah.
Okay? So the ones that are not regular, let's make sure that we use a straight edge to make sure our line segments are straight. Now, the ones that are regular, we need to make sure that we use something to measure the sides to make sure that we get them all. Do you understand? So they're all the same, okay? Whether it's a ruler or a piece of paper with the thing, all right? Now, 10 and 11. What kind of shapes? Okay, I know what you guys are going to do. You're going to all see these shapes. Okay? You're going to forget about shape B. That's all I'm going to say. Don't forget about shape B. You're going to circle the polygon that is a quadrilateral. You're going to describe the polygon seen as regular or not regular. That's it. Okay, here's polygon C. Shh. Number 14, explain why every square is a regular polygon. Well, this should be easy. All right? If you don't know, look up the definition of square in your book, and you'll know. Because if you don't know, now you know. All right. What? Number 15 also, it says, how can polygons be considered a subcategory of two-dimensional figures? This is what I'll tell you about that. Okay? Please close the door. You guys are all kids. So if I said my kids, I would be referring to all of you. Subcategory of kids. In this room we have girls. And we have boys. We have kids with glasses and we have kids without glasses. Why would those be considered subcategories where kids is the category?
Because they are different. Because we're all different?
Because everybody doesn't. Okay. I helped you with number 15.